Yes. Okay. Welcome, everyone. There was a delayed start, but we're going to catch up. Thanks for coming. 2110 troubleshooting. Who needs that? No one, right? So, we are gone. Thanks. If you still need troubleshoot 2110, I want to introduce you to something which is called NMOS BCP-008, a standardized way to report status from the end device. So who are we? First of all, Simplexity company I'm working for, consulting training based in Switzerland. And we do all kinds of things down to really detailed troubleshooting and things like this. And we are working independently of manufacturers. So we don't need to hide anything. We just, I want to talk a little bit down to earth, what we are facing every day and what we hear from our customers. So why is 2110 such a big topic? Why is it so complex? I've been thinking about this for some time, and I think it comes down to this. We have a paradigm change here. We once had a matrix, a box in the middle, and now it's a distributed system. So it used to be like this, a box in the middle, and you talk to that box, and if the control works and the box works, then everything's fine. And if you need to exchange an end device, you just plug in something else. If the monitor's gone, you plug in another monitor and off you go. Now, it's slightly different. With 2110, it looks something like this. You have a distributed system, and now in order to make a connection, you need to talk to every single end device. And unfortunately or fortunately, all of them can be made from a different manufacturer. So, in order to, it's really helpful to standardize how you talk to these end devices, and not just in a control way, but also in a monitor way. And that's what this is about. So let me introduce you to the problem statement here. First of all, we have all these components from different manufacturers. They need all to be flawlessly working together in order to basically replace the old-fashioned matrix. The end users are no IT experts. They don't know what's going on underneath it. They don't want to know, rightly so. And the point is, we need a simple status reporting for the end users, because they don't want to know all the bits and pieces. They just want to know my system is working. And what we have seen many times is there are lots of capabilities in all of these systems and devices to throw alarms. And that's not the problem. The problem is there are too many of them. I just called up an engineer some days ago, and I said, what's your problem with your 2110 system? And he goes, let me check. And he says, I've got 60 pieces of these high density gateways, that SDI IP 2110 gateways, 60 online. 50% of them are currently showing a warning, and another 20% a critical warning. And the problem is none of them are true. I simply ignore them. So we need to change that, because if we want to get something from the device meaningful, then we need to change that. So the point is, another problem is if you have a control system, the control system shows you something being connected, but what they actually show is just a setting you have applied to a device, not that it's actually receiving packets. That's a totally different story. And and if you use a traditional monitoring system, the required states are constantly changing. Like, where do the packets right now need to go? And is that run destination right or wrong? Because it changes basically per second. So you can't just monitor like you do power supplies, because the good state is they're up, the bad state is they're down. Now, all these required states are changing very dynamically. So what we need is a user interface, as I said, showing to the operator a green state or something, and it's all fine. And that green should actually represent a health, which is going down to packet level, and synchronization, and. Everything which is necessary for a working 2110 system should be taken into account when it shows green, and not just I apply the setting. So, since this requirement is identical to all the manufacturers and all 2110 end nodes, it will make very much sense to have not just a standardized way to control the connections, but also to have a standardized way to report a few very important states back to a user interface, to the control system. So that's exactly what BCP-008 is doing. Now, I don't want to use too much time on what BCP-008 is doing. I just give you a brief overview of what it does, and then I want to dig into some very real-life examples where BCP-008 helps a lot. So, and by the way, turns out that a simple user interface and the simple green lights and yellow lights, they help the experts too. They will be much faster in circling problems, even if they don't need them. They are very thankful for them. So, BCP-008, it's a traffic light approach. I already mentioned the green light. It has very simple rules, very generic rules. If something's green, it means the services are okay and there's no irregularities whatsoever. Yellow means the service is still okay. You don't have to worry. Your picture, your sound, everything's good. But maybe you want to check something is not quite right. And obviously red, you have an unhealthy service there. So the traffic lights, we reduce them to the max. That means every sender and every receiver on a network has to report 4 of these traffic lights, which we consider to be the most important ones. And there's a 5th one as a summary of those 4, saying, basically indicating the worst of the other 4, like all the members. Here are the, all in all, 5 traffic lights. The first of all is the overall state. As I said, it's just the worst of all of the others. And then the 4, which we think are very, very important and helpful, are 2 of them regarding connectivity. So basically one of them saying, I got all the links I need as a device, all up, 2 up, 3 up, 1 up, whatever you expect. Second one is I receive all the packets I need and there's no packet loss and also actually on time. So then it goes green. Second one is also hugely important, synchronization. I do have all the synchronization I expect. So this means if you expect BTP on 2 networks, then this is green. If one of the 2 isn't, then it's yellow because you still have one. And finally, stream validation. If you are able to decode the stream as a receiver, then you go green. So this is kind of the very short story of BCP-008. There are other presentations about it. I welcome you to look at those if you want to know more. So let's dig into the examples. I want to come up with some things which we have seen, and I picked some which are really a very good candidate where BCP-008 can help a lot. And the first one is this one. I'm going to tell the story first, and I'm not putting too much text on the slides because I want you to listen to me. It's just a storytelling session here. So the story goes like this. There is a journalist sitting in front of his PC and he's working, he's, editing audio and whatever, he's recording audio, he's playing back audio, and he's working with a virtual sound card. He's editing on the radio side or whatever. He has 2 connections to the wonderful -7 networks, A and B, all cool. And he works. And everything's fine until one fine day, it doesn't. And actually, it turns out this was during a service period of network A. So apparently, network B is not working. So what's happened? So this is the problem. Problem goes like this. This is a managed PC. This is a Windows PC managed by the central IT department. They run regular updates on the Windows. And one fine day, Windows decides that NICs, like network interface cards, which are not seeing the domain controller, the Windows domain controller, they are regarded as being unsafe. So Windows disables NIC2, but it doesn't shut down the link. It just disables it on a higher OS level. Well, the settings are still applied, right? The network, the control system says everything's connected, but point is NIC2 is not working anymore. So once he is dependent on NIC2 is a problem. It's like the old days when we only monitored one of the 2 power supplies and we didn't realize what the other one has gone for a long time. And once we need it, it's too late. It's exactly the same thing. So how would that show up on a BCP-008 equipped PC and system? Just using some examples, some through sources, through destinations. We see the destinations are connected to the journalist is connected to an external line here, top right corner. And if normally he would just work with his green lights, that's what he's used to. Now, one day he would see something like this. There is like a yellow dot and there's a 1 in there. It's actually the number of incidents which have been detected. And if he hovers with his mouse over that yellow dot, he would see something like packet loss on NIC 2. Now, even if he's not technical, he would probably figure out what a packet loss could be, or he would know who to call. And that's already enough. So if he clicks on it, he may be able to see more details. And now we see the 4 traffic lights. And now we also see there's actually a second one yellow in there. And we've only seen the most important one, NIC 2 having a packet loss. But of course, on NIC 2, there's also no sync in this case. So this is an example of how a user interface could indicate the problem. If you look at the journalist as a sender, similar thing. On the sender side, you couldn't tell there is packet loss because it's a UDP-based transmission. But if he hovers over that as a sender, he would see no sync on NIC 2 because it's true, there's no sync. And as a sender, you also need a sync. And if he goes into detail, he sees something like this, no sync on NIC 2. So he would know who to call before network A goes down. So this is one user story where it helps a lot. And you would have found this situation before it actually goes bad. This is something which happens almost on a regular basis, by the way, if you talk to people doing this kind of stuff. So, story number 2. No audio on one particular receiver. We just had a chat. We heard the talk before. WAN connections. You're a broadcaster. You have different sites. They are beautifully connected via rented lines, and you have a central processing somewhere in one of your buildings. Cool. Now here's the audio guy, and he's just. By the way, you have a large monitoring system overlooking everything. It's all cool. So you're done, right? Now there is the audio guy connecting multiple streams to his console, from the stage A to the console and B, C, whatever. And it's all connected. It all says connected. Now, if he checks, then, fortunately he does a line check and then he finds out, on receiver 12, there's no audio, but it's connected, right? Now he checks with the monitoring system even, and he finds there's traffic. The traffic he expects on that NIC, it's all cool. So still, there's no audio, so it's not cool. So what should I do now? Now, in this particular case, this is the explanation, basically just the summary. In this case, it turned out that receiver 2 was never intended to receive, it's sent up for a low latency connection. Was never intended to be connecting to a sender which is on the other side and another site. And the latency doesn't allow the packets to arrive on time. So basically all packets arrive, but too late. And in this case, that's probably a translator booth or something. He doesn't realize at that moment that the DSP for all of this is sitting somewhere else in a different building. And we all want to do distributed productions, right? So he shouldn't care about this anyway. But in audio, every millisecond counts. So this receiver was really set up for 2-3 millisecond latency, and the packets were just all late. So no system would indicate him that until he really looks into that particular product, that manufacturer. Now let's see how BCP-008 would indicate that. You have different sections of the console on the right-hand side. He's connecting stage 1, stage 2, whatever, and the translator. And he finds that where he connects the translator, there's a red dot in this case. So red means no service. It's really a problem. the counter actually goes to infinity because he has infinite problems right now. So if he hovers over that red dot, he finds late packets. These texts, by the way, are freely definable by the manufacturer. So I hope they're making a user-friendly code and not just an error code. If he checks and clicks the details, he finds something like this, late packets. Now, BCP-008 allows counters to be displayed as well in the details. In this case, he finds late 1,200,000 whatever thousand packets, lost 0. So then it becomes, to a reasonable technical person, it becomes already clear what's going on, right? So this is actually a problem, accidentally connected to a sender from another side. The latency settings were not right for this, and BCP-008 is the only way to show you that in a standardized way. So, deriving of that use case, I got you another one. There's a user and he looks at his panel. It's all green, but there's a digit number 2 on the top right corner there on the studio return. There's a number 2 showing. He doesn't have to care because it's all green. Somehow he's still curious, right? What's going on? So when he hovers over that, he would say something like this. Previously, link down on NIC 1. We encourage the manufacturers not to clear the messages, but just to prepend the word previously. It's a very simple, it's not a logging system inside the edge devices. That's still the job of the centralized control system to do that. But the edge device just does what it can do, and it, for instance, shows that error. When you check on the details, it shows the same thing. Previously linked down on NIC 1. Obviously, that happened twice. That's why the counter is there. In this case, you can think of maybe, depending on that multi-viewer or the situation, he can probably use his imagination a little bit and finds out, oh, someone has disconnected the cable twice. So it's okay. It's gone and he can reset the counter, no problem. Now, similar, but not quite, is this one. He has this little indication there, and it's green or yellow, it doesn't matter, and he has, again, an infinite counter there. Something happened, like a lot. And in this case, he hovers over it, and he finds link down on NIC 1. Same thing as before. And then he finds it's link down, link up, whatever. But the point is, it's not just a 2, it's an infinite. So something means the link has been up and down infinite amount of times. And that's a different root cause. Again, it doesn't take a lot of technical know-how to find out maybe there's a faulty connector or there's an SFP aging or something like this. It helps quite a lot. I got like 4 more use cases, but I'm running out of time. But anyway, another one. The guys on the distribution, they say, occasionally we see issues on the audio or video, but maybe once a month. Okay. We like those, right? Now in this case, it was a very, very tricky one. In this case, it was a playout system, and the playout system was set up according to a PTP recommendation, SMPTE 2059-2, version 2015. Version 2015 says you should announce PTP, the master, every quarter of a second as a default, and the timeout is factor 3. So after 0.75 seconds, you assume the PTP master is dead. Now, all the rest of the system is set up according to version 2021, which says you should announce every second, and the master is regarding as being dead after 3 seconds. So this is all the boundary clock setup. So it's not a problem. It's not proliferating everything, but this playout just again and again thinks the master's dead. And then he starts to think, oh, I should probably become the master. And it's occasionally starting to announce itself. It doesn't go anywhere because it's blocked by the boundary clock switches, but occasionally it just starts to become the master. So in this case, it was actually pretty tricky, but funny enough, this would also show up on BCP-008. it would look something like this. On the playout, on the right-hand side, you have a counter. In this case, it's 4. So 4 times something happens. I don't know yet what it is. So I hover over it with the mouse, and then there is something like this. Previously, there was a sync source change to something ending on 3A. It's a grandmaster identity, probably. So, okay, I see that on 2 of my receivers here. And then I can go to the details and I find that out as well. So the point is, I find out that there has been a sync change on the end device and it's reported back to me in a standardized way. Remember, none of these need any manual setup. It's a plug and play thing if people support BCP-008. So that's just one of the things. So I'm just looking at the time a little bit. There was something else. A TV station had interruption on all playout channels, all of them. In this case, the guy who was on duty late night, he found out that the 3 playout systems, mid-main and backup, they were all cool, but they had a spare playout, which wasn't used at all. It's really like emergency, right? And he found out that this guy is somehow doing strange, whatever, and he decides to reboot the spare system. It's not used. And he goes home. Now, at 3:00 a.m., the alarm hits the engineer on duty and says, hey, we got issues on all our playout channels, like on all channels. And then panic started on that TV. That happened. I mean, this is a real case. TV station goes like, oh my God, at 7 a.m., the CTO decides if we can't solve it by 8, we're just going to decide only to go on air with one of our channels because we have a sports thing coming up and it starts at 8 a.m. Panic. Now, this one was a really, really, really tricky one. And I'm going into some technical stuff and then I'm going to stop here. The spare system, when it got rebooted, somehow decided to issue a 2110 stream, which was faulty. It indicated a wrong packet length on the RTP level. And there was a receiver, one unit, which received that stream. It also received the streams from the working playout systems. It's basically a changeover unit. It's a one gateway, which is, in the heart of the system, doing all the playouts, by receiving the playouts, sending it on air. Now, the 4th one, which was spare, sent corrupted packets in. And that was never seen before, never tested before, but it ended up overflowing all buffers of that unit, including the healthy ones. And it was basically very, very difficult to circle that, because how would you find out? It was a reboot of that automatic change over IP gateway, which helped. But it took the expert of the experts of the experts like 3 hours to circle around that problem. And if you actually then, this is just a summary, if they would have checked a BCP-008 system, they would have seen the ACO, that changeover unit, reporting that it has a problem on channel 1 and 2 as well, right? And if you would have hovered, they would have found they are saying they have some packet loss or something. And the playout is fine. So, but they didn't get that. Again, this is probably one of the units throwing 60 alarms per second or something, and they learned to ignore it. So anyway, this is kind of a short summary. I would have 3-4 more cases, but I want to jump to the conclusions. BCP-008, you need it. And I think you should really ask manufacturers to implement it. It's a chicken and egg thing. If you don't ask, they won't do it. If they don't do it, you don't have it. So it identifies the real issue at the end device. The end device is your probe, not a second like monitor system somewhere. It needs the end device to report if it has a problem. So it increases the trust into an IP network as not anymore being a black box, because it shows you how it's doing. It enables faster diagnosis, resolution, even for the technical expert. They will love that because they can circle the problem really fast. And it operates independently of large monitoring systems. You still can run the monitoring systems. They love that because they get meaningful errors without any setup work. So that's pretty cool. And you have a lot less setup to do. So basically, it by the way, it allows expansion. If a manufacturer wants to report power supply failure, he can do it via BCP-008. So he just adds more traffic lights. It's not a problem. So basically, we think from the AMWA definitely that a BCP-008 is an indispensable addition to 0004 and 05, which takes care of your connections, just to know, yes, my system is actually doing what I told it to. Thank you so much.